Hi, so welcome back. In this video what I'm going to be doing is looking at question 7 from the SACE Specialist Mathematics Exam from 2019. Okay, this is another question from the booklet 1, and in this question what we're going to do is some complex number arithmetic. So the first part of question 7 was considering two complex numbers. One is we're going to call z, and it's equal to I, and the other one is w, and it's going to be the square root of 2 divided by 1 minus I. And so the first part of part 1 is we need to express z in exact polar form. Okay, so just to remind us what's going on, z equals I, okay, and arg of z then, well, if you imagine z equals I on an Argand diagram, you can see that's on the y-axis, and so the argument, which is the angle to the real axis in an anti-clockwise sense, is going to be pi over 2, okay, because it's 90 degrees or pi over 2 radians around from the real axis, and the modulus of z is going to be square root of 0 squared plus 1 squared, which is square root of 1, which is just 1, okay, because it's a distance 1 from the origin. And so if we want to write z then in polar form, we'd write it as r, in this case r is 1, and then CIS pi over 2. Okay, so that's the first part. Now we want to do the same thing in part 2, except now we're going to be dealing with w. Okay, so w is equal to the square root of 2 divided by 1 minus I. And to see what's going on, what we need to do is turn this into real and imaginary parts. And to do that, we need to get rid of the complex number on the denominator here. So we're going to multiply by 1 plus I over 1 plus I. That's just 1. But this is going to have the effect of turning the denominator into a real number. So on the numerator, we're going to get the square root of 2 multiplied by 1 plus I. And on the denominator, we're going to get 1 plus 1, which is 2. Okay, and so now we can write it in real and imaginary parts. We've got square root of 2 over 2, and we've got plus square root of 2 over 2 times I. Okay, so you can see the real and imaginary components the same size, and so that means it's going to be going out at a 45-degree angle from the origin. Okay, so as it's going out by square root of 2 over 2, or 1 on root 2, in the real direction and also in the imaginary direction. And so the argument of w is going to be pi over 4. Okay, you can also look at the imaginary divided by the real, and in which case this is 1, and then the arctan of 1 is pi over 4. And modulus of w, that's going to be the square root of the real part squared plus the imaginary part squared, and the real part squared is going to give us 2 over 4, and the imaginary part squared is going to give us 2 over 4, so that's altogether 4 over 4, or 1. So this is the same as before, where square root of 1 is 1, and so w is going to be equal to 1 CIS pi over 4. Okay, so that's part A. That wasn't too hard. Now, with part B, what we want to do now is draw and label Z, W, and Z plus W. Okay, so remember Z was I, so that's going up 1 unit on the imaginary axis. Okay, so we'll just indicate that with an arrow, and that's Z. Now W has also got a length of 1, and it's got an argument of pi over 4, and so that gets us to somewhere around there. That's W. And Z plus W, what we can do is we can complete a parallelogram and that gives us z plus w. Okay, you can see z plus w is calculated pretty much like you would do a vector calculation, right? You're just adding the real and imaginary part of z and w together, and we'll see what that looks like in the next part of the question. Okay, so that's zw and z plus w sketched and labelled on the diagram there. Now, what we want to do is say, using zw and z plus w from part B, show that the arg of z plus w is 3 pi over 8. And so what we can say is that since the modulus of z equals the modulus of w, remember they're both equal to 1, we have a rhombus. Okay, so the parallelogram that we completed on the Argand diagram is actually a rhombus. Okay, both all the sides are the same length. And when you have that and you draw a diagonal, the diagonal bisects the angle in the rhombus. So what that means is that the arg of z plus w is going to be equal to 1/2 the arg of z plus the arg of w. Okay, so that's 1/2 of pi over 2 plus pi over 4. Okay, when you add pi over 2 and pi over 4 together, you get 3 pi on 4, and then when you divide that by 2, you get 3 pi on 8. Okay, and it basically comes down to the fact that if you look back at this Argand diagram, this angle here and this angle here are equal. Okay, that diagonal z plus w is bisecting those two angles, and so you can take the midpoint of those two angles, if you like, or the average of those two angles, to give you the argument of z plus w. Okay, so question 7, part C, part 2, we want to write z plus w in Cartesian form. Okay, and we can do that just by looking at what the Cartesian form for z and w are independently and adding them together. So z, we've got this, just I, and for w, remember, we've got square root of 2 over 2 plus the square root of 2 over 2i, and therefore the real part is just the square root of 2 over 2, and the imaginary part is going to be 1, which is 2 over 2, plus square root of 2 over 2 multiplied by I. Okay, so that's the real and imaginary part. And so that's Cartesian form for z plus w. Okay, so now the final part, which is part C, part 3, is to show that the tan of 3 pi over 8 is equal to 1 plus the square root of 2. And the way we do that is by considering the arg of z plus w, because that's equal to 3 pi over 8. And the arg of z pi over w is arctan, or tan to the minus 1, of the imaginary part divided by the real part. And so in this case, the imaginary part is 2 plus root 2 over 2, and that's divided by the real part, and so that's 2 over root 2. And that's equal to 3 pi over 8. Now if we take 10 of both sides, then what we get is 2 plus root 2 over 2 times 2 over root 2 is equal to tan 3 pi on 8. And if we cancel out these 2's and we write this as 2 over root 2 plus root 2 over root 2, which is 1, we get tan of 3 pi over 8. And rearranging things slightly, we can say, therefore, tan 3 pi over 8 equals 1 plus root 2. Okay, because 2 over root 2 is just equal to root 2. And that finishes what we need to do for question 7. So if you enjoyed this video, don't forget to click the like button. And if you want to see when new videos are coming out, then subscribe to the channel. If you've got any questions or comments about the video, then you can post those below. And hopefully I can get to them pretty soon. All right, thanks very much.